All right, for this problem here, we're going to graph this quadratic onto this grid here. And this graph is in vertex form. And so just to recall what that looks like, this is going to be given as the general formula, y equals a times x minus h squared plus k. And some things to remember about this formula is the a value affects the shape, how wide, narrow, flipped, or right side up this thing is. The h and the k give us the vertex, and that vertex is given by h comma k. One thing to note here is that the h is going to be opposite to what we would assume would happen with the shifting. So notice this is a minus h, this is a positive h. These signs will always be flipped. The k, though, is going to stay whatever sign the k is. So moving towards this equation here for number one, the a value is 1, so the shape is going to be the same as my parent function. The concavity will be up. And here is my h, here is my k. And so my vertex is going to be -3, comma, -3. So you'll notice that I keep this -3 the same, and I switch. It's hard to see now, but that is a positive 3 on the inside. And so my vertex is going to be at -3. Once I have my vertex, it's time to start a table. So let's make a table here. X, Y values. X, Y. And all I'm going to do here is I'm going to put in the middle of my table my vertex. And it's important to put the vertex in the middle because we want to get a good picture of a few points to the left of my vertex and a few points to the right of my vertex. And I'm going to put my vertex on the table, on the graph right now while I'm at it here. Okay, and then from here, since I have my central point of the table, now I gotta take a couple points to the left on the x and a couple points to the right. So let's see, a couple points to the left would be -2, -1, or I guess that's to the right, but it doesn't matter. And then I have -4, -5. So here I've filled out a couple points on either side of my vertex, and to find the y's, all I need to do is plug in x. Plug in my x values to find my y. So let's start with -2. And if I plug in -2, I'm going to have y equals -2 plus 3 squared minus 3. And I have to be careful to follow PEMDAS here. So before I square anything or anything like that, I want to add what's going on inside these parentheses. So -2 plus 3 will give me a 1 squared minus 3, or y equals 1 minus 3, and y is going to equal -2. So let's put that -2 in here. And what I also know is these parabolas are symmetrical. So whatever is going to go in this piece here for -2 will also go in here for when x is -4. So that's going to reflect back over itself. So I've just found 2 points by finding that one. So that's great. That's when x is -2. And let's do the same thing now, but all I'm going to change is my x value when I start off. And let's make that a -1. So let's plug in this -1 for x. So if y equals -1 plus 3 is 2 squared, and I'm going to have a minus 3. So y is going to equal 2 squared is 4, minus 3. Y is going to equal 1. So that's what's going to go up here and down here. I've got 5 sets of points here. That's perfect, and that's enough to plot this guy. So let's plot -4, -2, -5, 1. And on the other side, I've got -2, -2, and -1, 1. And let's connect these dots. Let's go blue here. And here is my parabola. And now that I have my picture, I can actually state some properties for this thing. So if I were to talk about what the domain is, the domain is all of my possible x values. And for this quadratic and really all quadratics. My domain is going to be all real numbers. My range, this is where it gets a little bit more interesting. My range is all of my possible y values. So you can see my y values bottom out here and they go up. Everything below -3 is not going to be part of my range. So the way that I would describe that is y is greater than or equal to -3, since -3 is the bottom of my graph. This has a minimum at -3. It has an axis of symmetry at the line x equals -3. And that x equals -3 is a vertical line that goes through the vertex. It splits this thing in half. And that goes, the equation of this line is x equals -3. What else? I could talk about when this thing is increasing and decreasing. If I were to start at my vertex and move to the right, that's when my parabola is going up. So I'm going to be increasing when all my x values are to the right of -3. So when x is greater than -3, I'm increasing. I'm going to be decreasing when x is less than -3. Since at that point, I'm going down in the parabola until I hit my vertex. So there are some properties to take note of when we're graphing this thing, and I hope that helped.